Hello everyone, this is Aynaz. I will present my final project, which is about 5G enabled IoT and its security issues and mitigation. Here is the agenda. A wide range of applications, including remote surgery, self-driving cars, flying IoT drones, security and surveillance, and many more, are supported by a 5G-enabled Internet of Things communication environment. Every device and user in such a communication environment uses the Internet to communicate. Therefore, several security and privacy concerns plague this communication. Additionally, it is susceptible to a variety of potential threats, for example, man-in-the-middle, DOS, session key computation, physical devices stealing, and so on. Therefore, it is essential to defend the 5G-enabled IoT communication environment infrastructure from these attacks. 5G-enabled IoT architecture includes 5 layers. Recognition layer. IoT hardware and physical objects are the 2 key components of this layer. Connectivity or edge computing layer. This layer's job is to specify the networks and communication protocols that will be used by connectivity and edge computing. Support layer. It has computing capabilities, data analysis skills, and other sophisticated computer skills. Application layer. It is a terminal layer that provides a variety of applications and services. Business layer. All IoT systems are managed by this layer. Threats to security of 5G-enabled IoT. In 5G-enabled IoT, security and privacy are 2 major problems. Threats to privacy and security are quite expensive. In addition to possibly harming the financial penalty, it is also thought to have a negative impact on more urgent problems, including personal safety, social trust, and consumer confidence. Recognition layer. Hardware security. This layer is made up of many sensors, controls, and IoT gadgets. Sensors are susceptible to unauthorized access, tag cloning, and data reprogramming by the attacker. A user-accessible IoT device can be controlled by the malicious attacker, who can also supply false information. Software security. Software is vulnerable due to the integrity, availability, and authentication of any IoT device. Information from IoT devices may be taken, washed, and have its software functionality harmed if the embedding system is subjected to a malicious attack. The 2 harmful attacks that are most likely are code injection and cryptography. Connectivity or edge computing layer. Network security. Wireless jamming and distributed denial of service attacks are hazardous in an environment where edge computing is used. In this layer, man-in-the-middle attacks and fake attacks are also possible. Unauthorized intruders are even capable of faking identity, communicating normally, and obtaining more data from IoT users. Support layer, cloud computing. DOS attacks, shared cloud computing services, system flaws, and nefarious or careless insiders provide the biggest security risks in the cloud. Application layer, heterogeneous network. Multiple 5G-enabled IoT apps are present in this application layer, creating a heterogeneous network. Various application domains face unique security risks. However, these programs make it possible to communicate data over a heterogeneous network, which makes it simple for malicious code injection and denial of service attacks to occur. Business layer, data leakage. To assist with their modeling, the designers will create various APIs due to the demands in the business model design. Meanwhile, if the APIs are not secured, there is a significant risk of data leakage. The data may include a great deal of sensitive information, which will be quite expensive. Privacy threats. Location privacy. Location-based services are a core component of many IoT devices that support 5G. Global positioning systems are standard equipment in every smartphone and automobile. These services' main goals are to enhance users' quality of life and make their lives more convenient. However, if there is a privacy attack, the user's location data is also at danger. Attackers can forecast the user's activity patterns, interest locations, and lifestyle choices by using location data. Correlation privacy. The attackers will obtain more private information as a result of the increased personal and identity data that 5G-enabled devices will collect. The adversary will be capable of recognizing the specific information at the designated time, place, and so on after fragment data collected from numerous devices has been integrated and evaluated for correlation. To talk about the mitigations, group-based authentication is one method because the 5G core network only has one device with a SIM card connected to it, but multiple devices are connected to the network through hotspots. It's crucial to build a group-based authentication mechanism. Elliptic curve Diffie-Hellman. This key technique is employed to create phishing keys, making them impossible for an adversary to steal. Thus, this technique is utilized to provide data secrecy and shield the network against man-in-the-middle attacks. Blockchain, due to several core qualities that can give anonymity, data integrity, security, and etc., the attention on blockchain for various study topics is growing. Using blockchain and 5G technology, it is possible to trace a user's precise position in real time for the purpose of quick tracking. Digital signature. The message on the signer's secret key or private key are used to calculate a digital signature, a kind of public key cryptography to confirm the veracity and integrity of a communication. To ensure network integrity, the authentication procedure uses digital signatures. Lightweight cryptography. A network can be authenticated using a variety of lightweight cryptographic techniques such as one-way elliptic curve cryptography, hash functions, lightweight message authentication codes, and etc. Untraceability and user anonymity properties may be provided by making use of one-way hashing for authentication. The 5G network offers a number of benefits and has the flexibility to be adopted as the backbone network for the future IoT. There are 5 levels on 5G-enabled IoT, and in any of these layers, there could be several security threats and possible attacks that should be addressed. Here are the references, and thank you for listening.